Something that we're going to do a lot of now is proofs. Let's do a quick proof using the vertical angles theorem. We're asked to prove the following. In our figure, if angle 1 is congruent to angle 4, we need to prove that angle 2 is congruent to angle 3. A good place to start is by stating what we are given. Angle 1 is congruent to angle 4. How do we know that? Well, it's given. So that's what we're going to write down over here for our reason. Now remember, we just learned the vertical angles theorem, so let's use that really quick. If I look at angle 1, that is going to be congruent to another angle, angle 3 here. Angle 1 and angle 3 are congruent because of the vertical angles theorem. Now we can use the substitution property of equality to say that angle 3 is congruent to angle 4. All that we're doing is substituting angle 3 here in for angle 1 in the first statement. Now let's go back to the vertical angles theorem. That tells us that angle 4 is congruent to angle 2. So angle 4 is congruent to angle 2. Again, that's the vertical angles theorem. Because they are vertical angles, they are congruent. And once again, we are going to use the substitution property, and because angle 4 is congruent to angle 2, we're going to take angle 2 and substitute it into angle 4 in this first statement here. So that allows us to say that angle 3 is congruent to angle 2. And again, that is just the substitution property of equality. Now, because of the way I did this, I need a sixth and final step, because notice how they want us to make our final statement. Well, I need to say that angle 2 is congruent to angle 3. And what allows me to say that? That is the symmetric property of congruence. And I just realized just now that I've been using congruence all the time. So these are actually the substitution property of congruence. Wow, shame on me. And there we have it. We have just proved that given this figure, and that angle 1 and angle 4 are congruent, that means that angle 2 and angle 3 also have to be congruent. Yay! We are done.